Everyone. So you had a chance to work through those application problems. We're going to move on to a new set of success criteria, a new lesson. So here is the agenda for today. So we want to look at how sample size affects variability. Specifically, we want to explain the concept of sampling variability when we're making an inference about a population and see how the sample size affects that sampling variability. So we're actually not even going to do, there's no activity, there's no notes or paper for this particular criteria. All we're going to do is we're going to go back to that applet that we used when we were looking at the lyrics from Beyonce's song, and we're going to investigate what would have happened if we had sampled 20 words at a time instead of 5 words at a time. So method number one, we were selecting 5 words, human element. So this was a convenient sample. I'm just going to go through this really quickly. Okay, so I got an average of 5 letters per word. Okay, we're going to skip the convenient sample. We already know that's a bad method, leads to bias. So method number 2, you might recall, was when we used the random number generator to get a sample of 5 words. Okay, so I'm going to click on that button. Over here on the right, you can see the 5 words that the random number generator selected for me. And here I got an average word length of 3.2. Now, we don't have to just do one sample. In fact, when we did this in class, everybody took their own sample. And we ended up with that nice dot plot that you see on the back wall there. So I'm going to imitate that process here in the applet just by clicking the button multiple times. Okay, so you can see every time I tap the button, a new set of 5 words is being selected, and then a new dot is being added to the dot plot. And so we're basically updating this dot plot with the means of all these different samples. Okay, so I'm trying to generate enough so that we can kind of get a good idea for what the distribution looks like so that we can describe it. Okay. All right, that's pretty good. Now, scroll down, you see there was actually a third method. We didn't touch on this on that first day, but we're going to look at it now. So what if we had sampled 20 words from the song instead of just 5 words? All right. So here's our first sample. You can see now a random number generator is picking out 20 words from the lyrics. And then we have 1 dot right now on our dot plot to represent the average of just this first 20 word sample. But we can generate another 20 word sample and a third and a fourth and so on. All right, so let's generate a bunch of 20 word samples and compare the distribution we get from the 20 word samples to the distribution we get from the 5 word samples. And we're going to look to see, what is the main difference in these distributions. Okay. So there you can see both of them at the same time. Okay. Now, I could just keep tapping the button, or this website conveniently has a way that I can add a maximum of 2,000 samples with the click of just one button. So I'm going to add 2,000 more 5 word samples. And then I'll add 2,000 more of the 20 word samples. Okay, so now there's so many dots in each of these distributions that they just kind of look like stacks. They just look like lines now. Okay, but we have a much better picture of the distributions. All right, so let's go through SOC-V, right, and talk about how these two distributions compare. Okay. So the averages from the 5 word samples and the averages from the 20 word samples both have a somewhat, roughly symmetric shape. Okay, they're mound shaped. The left tail and right tail are more or less the same length for both of those distributions. Okay, we might describe maybe the 5 word samples as being slightly skewed to the right, but just only a little bit. Outliers, there don't appear to be any points that are unusually high or low. Okay. Center. So if we were to try to just kind of eyeball the center of the 5 word samples, it would probably be right around there, say maybe like 3.5. And in fact, I think that's what the true value was. I don't remember off the top of my head. It's written on the poster, so if you look at the back wall, it should say what the true value was. And then if we look at the 20-word samples, again, I would probably say that the center of that distribution is also around 3.5. Okay. So both of our distributions have more or less the same center, right? The same overall average, about a 3.5. Now, where they differ the most is their variability, right? There's a lot wider range of estimates that we're getting from the 5-word samples. You can see the minimum is kind of a little bit less than 2, and the maximum is kind of in the neighborhood of 6. Whereas the 20-word samples have much less variability, right? The lowest estimate here is probably like a 2.5, and the highest estimate is maybe high 4s, maybe a 5. Okay, so overall we have less variability from the 20-word samples than the 5-word samples. Okay, and actually having less variability is a good thing, right? What it really means is that the estimates that we're getting from those 20-word samples are more consistent, right? Those estimates are consistently closer to the true value. So, in a nutshell, when you take a larger sample size, 20 versus 5, the estimates will have less variability, right? Or the estimates will be more consistent. All right. Thanks for watching this video. You guys are going to start a new activity next. So your guest teacher will start you off on that activity. Once you do a couple questions, they'll play a video. You'll hear my voice again. All right. See you later.